Welcome to the lecture on problem solving on compounding frequency and equivalence. So, we will deal with a few questions and we will try to see that how it can be solved. So, in this lecture let us start with the question. Now, let us say the question is like you have nominal rate of 8% compounded monthly will result into effective interest rate of what percentage with a time interval of 2 years. So, we have discussed about these type of problems and we know that the equation is effective interest will be equal to 1 plus r by m and raised to the power l into m then minus 1. So, that way we have to use that formula and what are the values given, what are the data given, that we have to write first. So, what is available to us is that we have nominal rate is 8% compounded monthly. So, r will be 0.08. Then you have this is effective rate. So, it is compounded monthly and we know that the m is reciprocal of this compounding period in years. So, it will be 1 by 12. So, it will be m and L we know that L is the period for which you have to find the effective interest. So, it is 2 years. So, L will be 2. So, now we can have the effective interest rates formula being applied. So, effective interest rate will be 1 plus r by m into raised to the power l m minus 1. So, it will be 1 plus 0.08 divided by m. So, m is 12. Then raised to the power l into m, l is so m basically it is coming as 12 and then here you have 2 into 12 is 24 minus 1. So, if you look at its value, if you calculate it, it will be coming as 0.1729. It means it will be 17.29% per 2 years. Okay. So, for the interval of 2 years, if you calculate the effective interest rate, then that value comes out to be 17.29%. Then we can have another type of question. Now, in this case we have to find for suppose for nominal interest rate of what percentage the effective interest rate will be 12% when compounding is continuous. So, basically you need to know what will be the nominal interest rate when effective interest rate is 12% when there is a case of continuous compounding. And as we know that the effect this continuous compounding formula is e raised to the power r minus 1. So, what we do is that your e raised to the power r minus 1 and so it is given as 12%. So, it will be 0.12. So, you have to find this value e raised to the power r will be 1.12. So, you have to have you have to solve this. So, we can take the ln of on both these sides. So, r will be ln of 1.12 and it is coming as 0.1133. So, it means r is 11.33%. So, basically this value will be coming as 11.33% and that will be the answer in such cases. So, that is how we solve the problems related to the compounding frequencies, and we can have even several type of questions that you can practice. Next we may have a question like many a times you may face such kind of problems like the amount required at the end of year 4 to repay an amount of rupees 4 lakh. So, that it is borrowed today and the interest rate is 12% compounded quarterly. Will be. So, you have to find this amount which is required at the end of year 4 and the amount borrowed today is rupees 4 lakh and you have 12% compounded quarterly. So, we know that compounded quarterly means it will be 3%, effectively the effective interest will be 3% every 3 month, every quarter of the year. So, in fact what we have here is we have been given P as 4 lakh and then the interest rate here we have to take that as 12 by 4, that is 3% per quarter. Now, since we are going to have the money its value calculated after year 4. So, in this case if you take the time of compounding as 1 quarter or 3 months, in that case in 4 years you have the compounding 16 times. So, that is why n will be 16. Now, you can use the normal compounding factor formulas and you can find the value of f. So, f will be calculated as p into then f by p, I is 3 and n is 16. So, that is how you are going to calculate and it is nothing but 1 plus 0.03 raised to the power 16. So, this factor basically will be coming you can get it from the table and it will be coming as 1.6047. So, you have to have this value 4 lakh multiplied by 1.6047. So, it will be coming something close to 641,882 rupees. So, that is how you calculate this kind of problems. You solve such kind of problems when you are encountering such problems, and you can even find the effective interest rate also in such cases. And you can, if you take the effective interest rate, then suppose you are calculating the effective interest rate for year. So, it will be 1 plus and then you have to calculate this effective interest rate for 4 years. So, it will be again you have to 1 plus 0.12 by 4 raised to the power 4 minus 1. So, 1.03 raised to the power 4 minus 1. So, it will be something like 12.03 5%. So that also again multiplied by 4 times, and so that will give you this same thing. Then you may further have a question of some other type, like a person borrowed rupees 10,000 at 8% compounded annually. Now, the loan was paid according to following schedule. Repaid, the loan was repaid as per following schedule. So, you have a schedule given how this loan is being paid, and that schedule is that if your this is your N and this is your repayment amount. In that case, your in the first year you are paying 1,000, second year you are paying 3,000, and then you have the third year. So, third year you are giving 5,000, and in the fourth year you are giving X. Now, this you have to find this value, that is your X. In this case, this X is what? Now, you have to calculate what will be this X, so that this loan is repaid fully. This 10,000 rupees amount is repaid fully at the interest rate of 8% compounded annually. So, in that case, what you have to do is that you can have the mapping its value at a particular time, and then you can basically get that equation equated on both the sides, and then you can get the amount X. So, what you see that you are getting F1 as 1,000 and F2 as 3,000, F3 as 5,000 and F4 as X, and I is 8% and P is basically 10,000. So, if you take and equate the P to its sides, so P basically will be equal to, now this 1,000 is there. So, it has to be driven back one period towards left. So, it will be multiplied with the P by F factor. So, it will be P by F 10 1. Basically, it is nothing but 1 plus I raised to the power minus 1. So, then you have 3,000 multiplied by P by F I 2. So, this will be 8, this is 8 1. So, 8 2, and then 5,000 P by F 8 3 plus X P by F 8 4. Now, it is nothing but if you take P by F 8 1, it will be 1 by 1.08. Similarly, if you have this is 1 by 1.08 raised to the power 2. So, 1 by 1.08 raised to the power 3, and this will be 1 by 1.08 raised to the power 4. So, basically that will be used. So, all these values can be calculated, and as we know that this will be coming as 0.9259, then it will be 0.8573, and this is 0.7938, and this is 0.7350. So, if you solve this, so certainly all these values are known, only this is unknown, and P also we know that P is 10,000 here. So, this 10,000 is equated to it, and if you solve this, you will be getting X as 3446. So, something close to that you will be getting. So, you can just solve this equation and you will get. So, basically when you are given a table and you have to solve such problems, you can just solve this equation and get this value of x which is to be paid in any particular year, may it be third year or fourth year or first year. You have to just find the equivalent of the values on both the sides. Next we will have another question. So, we have a question like 5 years from now we have a future receipt. So, a future receipt of rupees 20,000 at 14% compounded semi-annually So, will be equivalent at present to how much? So, suppose you may face with certain type of questions that you have to have this from 5 years from now you have a future receipt of 20,000 and the interest rate is 14% compounded semi-annually. So, again you have to use this concept of the frequency compounding of interest. So, 14% compounded semi-annually means you are using 7% effective interest for the 6 months. So, and then once you have 7% interest for the 6 month, then the n becomes 5 into 2, that is 10. So, you have you can have the values. So, you have n will be coming as 10 and either or you can have you can calculate the effective interest value, because once you are using this compounding semi-annually. So, then you have to calculate the effective interest for the year. So, that will be 1.07 raised to the power 2 minus 1. So, it will be 14.49%. So, that way you can use it. So, you can have the effective interest also, or so there are two methods. One is n by 10, n equal to 10. So, in that case your 7% will be there, so 1.07 and raised to the power so 10, and it will be reciprocal of that. So, so minus 1. So, that will be the 1 plus, so that will be divided basically. So, that way when you take n equal to 10, you have to use 7% interest for 6 months. So, your interest rate will be I equal to 7, and that can be used. Or if you use n equal to 5 itself, in that case you have to find if n equal to 5 is to be taken, then in that case you have to find effective interest for the year for 1 year. Now, in that case effective interest for the year will be 1 plus 0.14 by 2 and raised to the power 2 minus 1. So, it will be 1.07 raised to the power 2 minus 1. So, it will be 0.1449. So, it will be 14.49%. So, in that case you have to use n equal to 5, or else you can use this when you go for the interest rate for this 6 month period. In that case you can take 0.07 as the n. Now, once you get so any of the method can be adopted, and then you have to find the value of the p. So, p will be basically, so in that case you have to multiply the f with the factor p by f I n. So, you can use any of these. So, f is given as 20,000, and then if you take the effective interest rate itself, so it will be 1 plus 0.1449 and then raised to the power minus 5. So, that is how you get it, and its value will be coming close to like 0.5083. So, in that case your value comes out to be 10,166 rupees. So, this can be seen, and also you can see from here for I equal to 14.49 and n equal to 5, or you could have taken I as 7 and n as 10 in that case. So, you will be getting the similar value of this, and that factor value is 0.5083. So, that will come out to be 10166. So, this way you can solve such kind of problems. Next type of question will deal with in the sense that what value of equal payment series is equivalent to present amount of rupees 65,000 in 6 years at 8% interest rate compounded quarterly with quarterly payments. Now, in this question what we see that your interest rate is 8% interest compounded quarterly. It means it is 2% interest rate every quarter, and also the payment is quarterly. So, you have 6 years. So, altogether you are going to have 24 payments, and for that you have to have the value of A required, that is equal payment series. So, the question tells that you will proceed in this fashion, that given amount is P as 65,000, and in this case you have n as 6 into 4, because it is quarterly payments, it will be 24, and I will be certainly 8%. So, 8% by 4, that is 2%. So, it will be 0.02, and then you have to find A. So, it is obvious that P will be, so you have A will be P into, and then you have the factor A by P I n. So, I is 2 and n is 24. Now, A by P we know the factors, you can look at the table, else you know the formula A by P I n is equal to I into 1 plus I raised to the power n whole divided by 1 plus I raised to the power n minus 1. That is the formula for A by P I n. So, you can use either this formula, or it is better to refer to the interest table, and this interest table if you look at, it is coming as 0.0529. So, this 65,000 will be multiplied with 0.0529, and this comes out to be close to 3438 rupees. So, basically if you are depositing 3438 rupees every quarter, every quarter, and the interest rate is 8% compounded quarterly, and every quarter basically interest rate is 2%. In that case, that value will be equivalent to the present value of rupees 65,000. So, if you look at in 6 years, otherwise if you look at since 34 or 3500 close to that into 4, so it will be 14,000, and into 6 years it will be 84,000. So, certainly since we are talking about the present time, so because of the interest rate it is coming to 65,000 of present time. So, that is how you can solve these problems. Then we may have another example of solving some different problems, like you have present amount is given as rupees 10,000 and future amount is given as rupees 30,000 and compounding is quarterly. So, you have to find what will be the effective annual interest rate. So, to find you have to find effective annual interest rate. Then you have to also find the nominal interest rate. Now, you have to find all these interest rates which will make P and MF equivalent for n equal to 6 years. So, now the thing is that we know that when they are to be made equivalent, in that case there are two things which are further required to be known. One is interest rate and another is your time. So, time is again given. So, you can have the value of the effective interest rate and also the nominal interest rate, but compounding is said to be quarterly. So, how to solve such problem? Now, in this case what we see is that we know that f is basically p into 1 plus I raised to the power n, because f is found by multiplying p with the factor f by p I n, and f by p I n is 1 plus I raised to the power n. So, f will be p into 1 plus I raised to the power n. So, this way we know that 1 plus I raised to the power 6 will be f by p, and f by p is basically 3. So, we can get its value. We can take the log on both the sides and we can get the value of I, and if you solve the I for I is coming as 0.201, that is 20.1%. Now, this 20.1% is basically the effective rate which is there. Now, what will be the R basically? Now, for R you have to use again the formula, because the compounding is done quarterly. So, you have to again use, that is I equal to 1 plus R by 4 raised to the power 4 minus 1. So, if you do that you will be getting the value of the R. So, let us say you can solve it. So, you will have you will be getting the expression for the R as, so 0.201, that is your effective interest. It will be 1 plus R by 4 and raised to the power 4 minus 1. So, this is basically the effective annual interest. Now, as we are talking about the quarterly compounding, so you have m is 1 upon 1 by 4, that is 4. So, m is coming as 4 here, and then since we are talking about the effective annual interest, so L is 1. So, 4 into 1 is 4 minus 1. So, this way you can have the value of R, and R is coming as 18.7%. So, basically this is your 18.7% is coming out to be the nominal interest rate in such cases. So, this is how you are you have to use these concepts of interest and equivalence to find the value. There maybe we can solve furthermore one question, like you have, suppose you have single amount at the end of 5th year, which will be equivalent to uniform annual series of rupees 20,000 per year for 12 years at 7% compounded annually will be how much? So, you have to calculate this single amount at the end of 5th year, which will be equivalent to the uniform annual series of rupees 20,000 per year for 12 years. So, such problems, for that we know that we are given A as 20,000 and I is given as 7%, and we have to have the value F5, that is your equivalent future value at n equal to 5. F5 is required to be known. Now, for that we will be calculating first the P, and then ultimately we are going to use the formula for finding this future value at the time n equal to 5. So, F5 and then you have P by F and 7.5. This will give you the present value of this F5. So, F5 will be multiplied by P by F 7 and 5. So, that is coming as P. Now, again you have to convert this 20,000 to the equivalent P. So, for that this 20,000 will be multiplied. So, this is A. So, you are going to multiply with factor P by A in. So, this will be multiplied with P by A 7, and this is going for 12 years. So, P by A 7 12 is coming out to be 7.9427, and this is 0.7130. So, if you solve, other things are known. So, F5 if you calculate, it is coming as this is 20,000. So, that will be coming as 22279. So, this is how 22279.6. So, that is how you are going to get its value. So, because you are going to deposit this 20,000 for 12 years, and then you are getting its P, and then further you are coming 5 years down the line. So, you are getting this value. You can solve this and you can get these answers and get your confidence boosted by solving the different type of questions from the books. Thank you very much.